In the vast expanse of our solar system, a celestial dance unfolds, a symphony of motion orchestrated by gravity's invisible hand. Planets twirl around our sun, their paths etched across the cosmos like celestial brushstrokes. Around these giants, smaller bodies pirouette, moons caught in an intricate ballet. Among them is Telesto, a tiny moon caught in the gravitational embrace of ringed giant Saturn. Telesto is a small moon, barely a whisper in the cosmic choir. Yet like every celestial body, it holds a story. Saturn, the sixth planet from our Sun, is a gas giant of immense proportions, adorned with a dazzling system of rings. These rings, composed of countless icy particles, are a testament to the planet's turbulent past and the gravitational forces that shape our universe. Within this majestic system of rings and moons, Telesto plays a unique role. It shares its orbit with two other moons, Calypso and Tethys, forming a gravitational trio. Join us now as we embark on a journey to Telesto, a tiny moon with a giant story to tell. Imagine a celestial waltz, a trio of dancers moving in perfect harmony. This is the story of Telesto, Calypso, and Tethys. They are locked in a gravitational dance around their massive partner Saturn. Telesto, the smallest of the three, is an enigma wrapped in a mystery. Discovered in 1980 by a team of astronomers using ground-based telescopes, Telesto was initially just a blip on a screen. Spacecraft like Voyager and Cassini have provided us with glimpses into Telesto's world. They have sent back images revealing a heavily cratered surface, a testament to the moon's long and tumultuous history. Telesto's story is a reminder that even the smallest celestial bodies can hold clues to the universe's grandest events. Saturn, a ruler of the outer solar system, commands attention. Its rings, a celestial halo, are a spectacle that has mesmerized humanity for centuries. But Saturn's beauty is not just skin deep, it extends to its entourage of moons, each one a world unto itself. There's Titan, shrouded in a thick atmosphere, a moon that holds the potential for life as we know it. Enceladus, with its geysers erupting from its icy surface, hinting at a hidden ocean beneath. And then there's Telesto, a tiny dancer caught in the gravitational pull of this planetary giant. By studying Telesto, we gain a deeper understanding of Saturn's history, its formation, and the forces that have shaped this majestic planet and its retinue of moons. The year was 1980. The world was a very different place. Disco was fading, and personal computers were just beginning to enter our homes. Yet, in the realm of astronomy, a new discovery was about to make headlines. A team of astronomers, led by Brad Smith, were using ground-based telescopes to observe Saturn. They weren't specifically looking for new moons. Instead, they were studying Saturn's faint rings, hoping to learn more about their composition and structure. As they peered through their telescopes, they noticed a faint speck of light, a tiny point of light moving against the backdrop of Saturn's majestic rings. It was orbiting the ringed giant, a previously unknown moon. They named it Telesto, after a daughter of Oceanus and Tethys in Greek mythology. The discovery of Telesto was more than just adding another name to the ever-growing list of Saturn's moons. It was a window into the past, a clue to understanding the complex processes that shaped our solar system billions of years ago. Astronomers believe that Telesto, along with Calypso and Tethys, are remnants of a larger moon that once orbited Saturn. This ancient moon, torn apart by Saturn's powerful gravitational forces, left behind these three smaller moons as celestial debris. Their very existence challenges our understanding of moon formation and the dynamics of planetary systems. The existence of Telesto, Calypso, and Tethys suggests that moons can also form from the fragmentation of larger bodies. The early images of Telesto were grainy, captured by ground-based telescopes that struggled to pierce the veil of Earth's atmosphere. But as technology advanced, so did our view of this tiny moon. In the 1980s, NASA's Voyager spacecraft flew past Saturn, sending back the first close-up images of Telesto. It wasn't until the arrival of the Cassini spacecraft in 2004 that we truly began to appreciate the complexity of Telesto. Cassini's images revealed Telesto to be a world of surprising diversity. Its surface, once thought to be smooth and featureless, was revealed to be heavily cratered, a testament to billions of years of impacts from asteroids and comets. These craters are like windows into Telesto's past, each one telling a story of cosmic collisions and celestial violence. Imagine holding a cosmic marble between your fingers, a tiny world dwarfed by the vastness of space. That's Telesto, a moon so small it would barely register as a blip on a map of Earth. Measuring a mere 24 kilometers or 15 miles across its longest axis, Telesto is a celestial lightweight. Despite its diminutive stature, Telesto is a world unto itself, a celestial body shaped by the same cosmic forces that have governed the evolution of planets and stars. Its surface, though scarred by time, holds clues to its formation and the violent history of our solar system. Telesto's very existence challenges our understanding of moon formation and the delicate gravitational ballet that governs our solar system. Telesto's surface is a canvas etched by time, a testament to the relentless bombardment of asteroids and comets that has shaped our solar system since its birth. Craters, some spanning tens of kilometers, pockmark its icy exterior, each one a silent testament to a violent impact from epochs past. These craters, like wrinkles on an aging face, tell a story of cosmic collisions, of celestial bodies colliding in the darkness of space. Some craters are deep and well-defined, their rims sharp against the surrounding terrain. Others are shallower, their edges softened by time and the slow but steady erosion caused by micrometeoroid impacts and the constant rain of charged particles from Saturn's magnetosphere. Peering beneath Telesto's heavily cratered surface, astronomers believe they are looking at a world dominated by ice, a celestial snowball hurtling through the frigid depths of space. The precise composition of this ice remains a subject of ongoing research, but it is thought to be primarily water ice, perhaps mixed with other frozen volatiles such as ammonia or methane. These ices, relics from the early solar system, hold clues to the conditions that prevailed when Telesto and its siblings were forming billions of years ago. The presence of these ices also hints at the possibility of a subsurface ocean, a hidden reservoir of liquid water trapped beneath Telesto's icy shell. However, detecting such an ocean, hidden beneath kilometers of ice, would require sophisticated instruments and dedicated missions to this enigmatic moon. Gazing upon Telesto through the lens of a powerful telescope, one might be forgiven for thinking it a drab and monotonous world, a grayish-white sphere devoid of color or contrast. However, a closer look reveals a world of subtle hues, a delicate interplay of light and shadow that hints at the complexity of its surface composition. Telesto's surface, though primarily composed of ice, is not a uniform white. Instead, it is a tapestry of grays, whites, and faint hints of other colors, suggesting the presence of different types of ice and perhaps even trace amounts of rocky minerals. By analyzing the wavelengths of light reflected from Telesto's surface, scientists can infer the composition of its surface materials, identifying the presence of different types of ice and other compounds. These data provide valuable insights into the moon's formation and the processes that have shaped its surface over billions of years. Imagine a celestial waltz, a graceful and intricate dance of celestial bodies, choreographed by the invisible hand of gravity. In this cosmic ballet, Telesto plays a unique role, its movements intricately linked to those of its larger companions, Saturn and Tethys. Telesto is a Trojan moon, a term used to describe a moon that shares the orbit of a larger moon, locked in a stable gravitational dance. In Telesto's case, it shares its orbital path with Tethys, a much larger moon of Saturn. As Tethys glides around Saturn, Telesto follows closely behind, always maintaining a distance of approximately 60 degrees in its orbital path. The gravitational pull of massive Saturn creates stable points in Tethys's orbit, known as Lagrange points, where the gravitational forces of Saturn and Tethys balance perfectly. To understand the delicate gravitational dance of Telesto and Tethys, imagine a cosmic balancing act, a celestial seesaw with gravity as the invisible force. The Lagrange points, named after the Italian-French mathematician Joseph Louis Lagrange, are regions in space where the gravitational forces of two large bodies, such as Saturn and Tethys, create stable equilibrium points for a smaller object, like Telesto. Telesto occupies the L4 Lagrange point, located 60 degrees ahead of Tethys in its orbit around Saturn. At this precise location, the gravitational pull of Saturn and Tethys combine in such a way that Telesto experiences a net gravitational force that keeps it in a stable orbit. It's like a cosmic balancing act, where Telesto is perfectly positioned to remain stable within the gravitational tug-of-war between Saturn and Tethys. From our vantage point on Earth, Telesto's journey around Saturn might seem like a slow and stately affair, a celestial waltz played out over eons. However, from Telesto's perspective, the experience would be anything but leisurely. Telesto races around Saturn at a speed of approximately 34,000 kilometers per hour, or 21,000 miles per hour, completing one orbit every 45 hours. During its journey, Telesto witnesses the grandeur of Saturn's rings from an ever-changing perspective, the icy particles sparkling like a celestial halo against the backdrop of space. Despite its rapid speed, Telesto's motion is remarkably stable, a testament to the precision of its gravitational dance with Tethys and Saturn. This stability makes Telesto an ideal laboratory for studying the dynamics of planetary systems and the subtle interplay of gravitational forces that govern their movements. Telesto's most striking feature isn't something we can see on its surface, it's the way it moves. Telesto is a Trojan moon, and that makes it part of a very exclusive club in our solar system. The name Trojan might make you think of ancient Greece and epic battles, and you wouldn't be entirely wrong. These moons are named after the Trojan asteroids, a group of space rocks that share Jupiter's orbit around the Sun. Just like those ancient warriors camped outside the walls of Troy, Trojan moons are trapped in specific spots in a planet's gravitational field called Lagrange points. Telesto isn't alone in its Trojan dance around Saturn. It shares this special relationship with another moon, Calypso. Calypso occupies the L5 Lagrange point of Tethys, which puts it 60 degrees ahead of Tethys in its orbit. Imagine these three moons, Tethys, Telesto, and Calypso, as dancers moving in a celestial waltz around Saturn. Tethys leads the way, gliding gracefully around the ringed giant. This delicate gravitational dance, a testament to the intricate workings of our solar system, is a phenomenon that has captivated astronomers for decades. When you think of moons, you might picture heavily cratered surfaces, scarred by billions of years of impacts from asteroids and comets. While Telesto has its share of craters, it's surprisingly smooth compared to many other moons in the solar system. Think of our own moon, its face riddled with craters of all sizes. Telesto, on the other hand, has a much smoother complexion. Astronomers believe this smoothness is due to Telesto's composition and its location in Saturn's system. Telesto is thought to be primarily composed of ice, which is much more malleable than rock. Over time, impacts that would have left deep craters on a rocky surface might have created only shallow depressions on Telesto's icy exterior. These impacts, instead of blasting out craters, might have caused the ice to flow and reform, smoothing out its surface over eons. One of the most intriguing mysteries surrounding Telesto is its potential to be brighter than expected. Early observations suggested that Telesto might be highly reflective, reflecting almost all the sunlight that hits it. This was unexpected, given its presumed icy composition. Ice is usually quite reflective, but not to the degree initially observed for Telesto. This led to speculation that Telesto might be covered in a thin layer of highly reflective material, perhaps something like frost or very pure water ice. However, more recent observations from the Cassini spacecraft have cast some doubt on these early findings. Cassini's data suggests that Telesto's reflectivity might not be as high as previously thought. The mystery of Telesto's brightness is still being unraveled, and it highlights how much more we have to learn about this small but intriguing moon. Telesto, despite its small size, holds significant clues to the grand story of our solar system's formation. Like an ancient artifact unearthed from a cosmic dig site, Telesto's very existence helps to refine our understanding of the processes that governed the early solar system. Its Trojan relationship with Tethys, for instance, suggests that both moons might be remnants of a larger parent body that was torn apart by Saturn's powerful gravitational forces. This process of fragmentation, a celestial game of cosmic billiards played out over eons, is thought to have been common in the early solar system. Studying Telesto's composition and orbital dynamics provides valuable data points for models of planetary system formation. By comparing Telesto's characteristics to those of other Trojan moons and asteroids, astronomers can refine our understanding of how these objects formed and evolved over billions of years. Telesto's significance extends beyond its individual story. It serves as a fascinating example of the intricate gravitational relationships that govern our solar system. As a Trojan moon, Telesto exemplifies the concept of orbital resonance, a phenomenon where two or more celestial bodies exert a regular, periodic gravitational influence on each other. In Telesto's case, it is locked in a one-to-one orbital resonance with Tethys, meaning that for every one orbit Tethys makes around Saturn, Telesto completes one orbit as well. This delicate gravitational dance, maintained over vast distances and timescales, is a testament to the power of gravity to sculpt the architecture of our solar system. Studying such resonances provides insights into the long-term stability of planetary systems and the factors that can lead to their disruption. Telesto, in its elegant dance with Tethys, reminds us that even seemingly insignificant objects can play a crucial role in the grand cosmic ballet. While Telesto has revealed much about the Saturn system, it remains a tantalizing target for future exploration. Its potential subsurface ocean, hidden beneath its icy shell, beckons with the possibility of harboring life-bearing environments. Future missions equipped with ice-penetrating radar could peer beneath Telesto's surface, searching for evidence of liquid water and potentially even hydrothermal vents, similar to those found on Earth's ocean floor. Beyond its potential for harboring life, Telesto offers a unique opportunity to study the effects of Saturn's magnetosphere on small icy moons. Its surface, exposed to the constant bombardment of charged particles from Saturn's powerful magnetic field, likely holds clues to the complex chemical interactions that occur in this extreme environment. Future missions could analyze Telesto's surface composition in greater detail, searching for organic molecules and other compounds that might shed light on the prebiotic chemistry that may have led to the emergence of life on Earth. Telesto's location in the Saturn system makes it a valuable stepping stone for future missions to the outer solar system. Its proximity to Enceladus and Titan makes it an ideal base for studying the Saturnian system. Future spacecraft could use Telesto to deploy landers and probes, exploring habitability and geological processes. Telesto's weak gravity and lack of atmosphere make it easy for spacecraft to rendezvous and orbit. It's an attractive option for testing technologies for exploring small bodies like Pluto and Eris. Telesto represents a gateway to further exploration beyond Saturn. Telesto, a seemingly insignificant point of light in the vastness of space, has revealed itself to be a world of surprising complexity and scientific value. More than just a tiny moon caught in Saturn's gravitational embrace, Telesto serves as a cosmic laboratory, offering insights into the formation of our solar system, the intricate dance of gravity, and the potential for life beyond Earth. Its unique Trojan relationship with Tethys, its surprisingly smooth surface, and the lingering mystery of its brightness all beckon further exploration, urging us to unravel the secrets hidden beneath its icy exterior. As we continue to explore our cosmic neighborhood, Telesto stands as a reminder that even the smallest of celestial bodies can hold profound secrets, waiting to be unlocked. Future missions, armed with advanced instruments and driven by insatiable curiosity, will undoubtedly unveil even more wonders hidden within this enigmatic moon. Perhaps beneath its icy shell lies evidence of a subsurface ocean teeming with possibilities. Or maybe Telesto holds clues to the very origins of life itself. The answers to these questions and countless others await us in the depths of space, beckoning us to continue our journey of discovery. Telesto, once a mere blip on a telescope's field of view, has captured our imaginations, reminding us that the universe is full of surprises, waiting for us to explore and understand. As we venture further into the cosmos, guided by the light of distant stars and the allure of the unknown, Telesto will continue to serve as a beacon, reminding us that even the smallest of worlds can hold the greatest of wonders.